Hello everyone, this is Vasant, a nine-pointer at IIT Bombay from the Department of Civil Engineering. In this video, we are going to solve a problem on torsional loading. So this is the problem. You can read it. The problem says that there is a circular tube of aluminium is subjected to torsional loading by torques T applied at the ends. You can see the figure over here. So the bar is 0.75 meters long and inside and outside diameters are given, that is 28 millimeters and 45 millimeters respectively. It is determined by measurement that angle of twist is 4 degrees when the torque is 700 Newton per meter. Newton dot meter. Calculate the maximum shear stress tau max in the tube, the shear modulus of elasticity G, and the maximum shear strain gamma max. Okay. Next. First, let us do the part A. For part A, first let us calculate given we already know phi is equals to T into L divided by Gj, right? So value of T is given. T is 700 Newton dot meter, and we know the value of angle of twist. Okay, angle of twist phi is equals to 4 degrees. Let us change it into radians. So into 180 divided by pi. Next, that's it. Now G value we don't know. Length is 0.75 meters. So again value of J. For J, what I said, first we need to find out mass moment of inertia of the circular tube. So mass moment of inertia will be mr square, right? So we will get J has 5 by 32 d2 power 4 minus d1 power 4. Okay. So that will be 5 by 32. What is d2 value? Let us put that in later. So now phi is equals to TL divided by Gj. So we need to find out G. G is equals to TL divided by phi J. So now let us put the values. G is equals to T is 700 Newton meter. L is 0.75 meter divided by phi is 4 into 180 divided by pi. No units. Into J. J will be pi by 32 into d2 power 4. d2 is 45 mm. So 45 power 4 minus 28 power 4 into mm power 4. Okay. So we get 700 into 0.75 into 32 pi divided by 32. Yes. This pi gets cancelled. So 32 4 into 180 into 45 power 4 minus 28 power 4 into Newton meter square divided by mm power 4. Right. So let us put this value in calculator. So 700 into 0.75 into 32 divided by 4 divided by 180 divided by 45 power 4 minus 28 power 4. Okay. So see Newton meter square divided by mm power 4, right? So this is mm square. So if we convert this into 10 power 6 mm square, so this mm square will get cancelled and we will get mm square. So we will get Newton mm square, right? So into 10 power 6 megapascals, right? So and we know that T value is 700 given, L value is given 0.75. This is pi by 32 into D2 power 4 minus D1 power 4. Yes. So on solving, we are getting 22 gigapascals. Okay. Giga means 10 power 9. So now we got modulus of elasticity G. That value is fixed. Whatever, if you change the diameter, that doesn't matter because the material is same. So the maximum shear strain we need to find out and the maximum shear stress. Okay. So if you go to B, sorry, in A, maximum shear strain gamma max is equals to R phi divided by L, right? What is R? R will be 45 by 2, right? 45 by 2 mm into this will be 4 degrees. So see 360 degrees scale 2 pi. So 4 degrees scale. So 4 by 360 to 2 pi. So 180. So that will be 4 pi divided by 180. Okay. So here also it should be 180 and it should be pi. And it should be 180 and it should be pi. Okay. Pi square. So now this is 4 pi by 180. So 4 pi by 180 into this is divided by L. L is 0.75 meters. So into 100 mm. So gamma max will be 45 into 4 pi divided by 360 into 0.75 into 100. Let us calculate this value. We get 45 into 4 into shift pi divided by 360 divided by 0.75. So we are getting this value as 2.09 into 10 to the power minus 3. Okay, this is gamma max. Then tau max will be is equals to G into gamma max. We know G, right? G is 22 gigapascals into 2.09 into 10 power minus 3, right? So into 22. So that will give us 46 megapascals. This is tau max. So we completed tau max, we found out tau max, gamma max, and G. Part A is complete. So now let us go to part B. In part B, he's saying that if the maximum shear strain in the tube is limited to 2.2 into 10 power minus 3. Gamma max is 2.2 into 10 power minus 3. So, and the inside diameter is increased to 35 mm. What is the permissible torque? Okay. Now D2 will be 45 mm. That is as is. But D1 will be is equals to 35 mm. Okay. So we already know the value of G now. The material is aluminum. Whatever you change the diameter, but the material is aluminum, and we assume that it is homogeneous and isotropic. So the value of G will be same. Whatever conditions you change, means we are assuming that it is in linear elasticity of modulus. So 22 GPa. Okay. So we need to find maximum. Okay. So we know that tau max is equals to G gamma max, and we know that tau max is gamma max is equals to R phi divided by L. Phi is TL divided by GJ, right? So we get R divided by L into TL divided by GJ. So L gets cancelled. So gamma max will be is equals to T R divided by GJ. So T will be T max that can happen will be is equals to GJ gamma max divided by R, right? So J will be again pi by 32 into D2 power 4 minus D1 power 4, right? So T will be is equals to 22 gigapascals into J, that is pi by 32 into 45 power 4 minus 35 power 4 power 4 into gamma max is 2.2 into 10 power minus 3 divided by radius. Maximum radius is 45 by 2 right? So if we calculate this term, will be is equals to 22 into 5 into 45 power 4 minus 35 power 4 into 2.2 into 10 power minus 3, right? Divided by 32 means 16 into 45. 16 into 45, and the units are gigapascal into mm power 4 into, that's it, divided by m. Okay. So now let us calculate the value. 22 into shift I into 45 power 4 minus 35 power 4 into 2.2 divided by 16 divided by 45. So we are getting, sorry, this is T, right? T max will be 549,080, okay, into 10 power minus 3 gigapascals into mm cube, right? So this will be 10 power 9 into, we can write 10 power 6 into, sorry, 10 power 3 into megapascals. Megapascals means Newton mm square. So that will be mm cube. So that will be 549,080 into 10 power minus 3 into 10 cube Newton mm. So that will be 54.908. Okay, this is the final answer. With this, we end today's lecture. Thank you.